Structure and bonding of elements and compounds. Atoms bond if there is space in their outer electron shells for more electrons. Thus, the noble gases with their full outer shells don't easily form bonds. In an atom, the inner complete shells of negatively charged electrons are held tightly by the positively charged protons in the nucleus. However, these inner electrons will shield some of this nuclear charge from the electrons in the outer shell, which will only feel this excess charge. Thus, in chlorine, the inner 10 electrons will cancel out or neutralize the effect of 10 of the protons. So the outer 7 electrons feel an effective charge of just 7+, holding them in their outer shell. Sodium, with 11 protons and 11 electrons, has also 10 inner electrons, leaving an effective charge of only +1 to hold its single outer electron. Thus we see why non-metals with nearly full shells hold on to their electrons more strongly than metallic elements with nearly empty shells. We also see why atoms bond. If there is a space in their outer shells, electrons from other atoms can be attracted in by this effective nuclear charge, but only until the shell is full.
Nucleus with protons and neutrons in it. Protons are positively charged and neutrons have no charge, so the nucleus is positively charged. Protons and neutrons are collectively called nucleons. Electrons are negatively charged and are located around the nucleus. An atom has the same number of negatively charged electrons as it has positively charged protons in the nucleus. Therefore, atoms are electrically neutral. Electrons are distributed in a definite path around the nucleus and are called shells or orbits. This concept was introduced by Niels Bohr. According to Bohr, different electrons revolve around the nucleus in their own different orbits. The atom has been compared to the solar system. In an atom, the nucleus is the sun and the electrons are the planets. Just like planets in the solar system, each electron revolves around the nucleus in its own different orbit. The orbits or shells are represented by the letters K, L, M, etc. The maximum number of electrons present in a shell is given by the formula 2n², where n is the orbit number of energy cells. The first orbit or K shell can have 2, the second orbit or L shell can have 8, and M shell can have 18 electrons, etc. The electrons present in the outermost shell of an atom are called valence electrons, and the shell which valence electrons occupy is called the valence shell. A molecule is in general a group of 2 or more atoms that is chemically bonded together. Atoms combine chemically by external forces such as heat and light. This leads to the formation of molecules. During the formation of a molecule, atoms lose their valence electrons or gain electrons from other atoms. For instance, if 2 pieces of wax are to be joined, they are heated. After heating, the 2 pieces are pressed together to form a single structure. Here, heat is the chemical factor which is responsible for joining the molecules of wax pieces. There are 2 main types of bonds, covalent and ionic.
The strong force that holds together the constituent particles, atoms, ions or molecules in a chemical species is known as chemical bond. The chemical bonds are broadly classified as ionic bond and covalent bond. Let us discuss these chemical bonds in detail in this module. The bonding which results due to the complete transfer of valence electrons between atoms is called ionic bonding. It is a type of chemical bond that generates 2 oppositely charged ions. Ionic bonding is observed because metals have few electrons in its outermost orbital. By losing those electrons, these metals can achieve noble gas configuration and satisfy the octet rule. Similarly, non-metals that have close to 8 electrons in its valence shell tend to readily accept electrons to achieve its noble gas configuration. In ionic bonding, more than 1 electron can be donated or received to satisfy the octet rule. Sodium metal has electronic configuration as 2, 8 and 1. It has 1 electron more than a stable noble gas structure. If it gives away that electron, it would become more stable. On the other side, chlorine has electronic configuration as 2, 8 and 7. It has 1 electron short of a stable noble gas structure. If it could gain an electron, it too would become more stable. Thus, the sodium atom donates its valence electron to achieve stable octet configuration. This creates a positively charged cation due to the loss of electron. The chlorine atom receives one electron to achieve its stable octet configuration. This creates a negatively charged anion due to the addition of one electron. The sodium ions and chloride ions are held together by the strong electronic attractions between the positive and negative charges. Covalent bonding. A covalent chemical bond results from the sharing of electrons between two atoms with similar electronegativities. The electronic configuration of chlorine atom is one electron short of the argon configuration. The formation of the chlorine molecule can be understood in terms of the sharing of a pair of electrons between the two chlorine atoms, each chlorine atom contributing one electron to the shared pair. In the process, both chlorine atoms attain the outer shell octet of the nearest noble gas, that is argon. The dots represent electrons. Such structures are referred to as Lewis dot structures. Thus, the chlorine atoms are joined by a single covalent bond. A single covalent bond is formed when one pair of electrons are shared between two atoms. It is depicted by a single line between the two atoms. A double bond is formed when two atoms share two pairs of electrons with each other. It is depicted by two horizontal lines between two atoms in a molecule. This type of bond is much stronger than a single bond, but less stable. This is due to its greater amount of reactivity compared to a single bond. For example, in the carbon dioxide molecule, we have two double bonds between the carbon and oxygen atoms. When three pairs of electrons are shared between two atoms in a molecule, a triple bond is formed. It is the least stable out of the three general types of covalent bonds. The two carbon atoms in the ethyne molecule are joined by a triple bond.
A simple way to remember the types of bonds is, in ionic chemical bond there is the transfer of electrons, and, in covalent bonds, there is sharing of electrons. There are four types of covalent bonds: single covalent bond, a bonding in which one electron is shared; double covalent bond, in which two electrons are shared; triple covalent bond, in which three electrons are shared; and tetracovalent bond, in which there are 4 electrons shared. Thank you for watching this video. Hit the like button and also subscribe to my channel. Have a good day.